Hey everyone and welcome! Today we're jumping into two shapes you probably see all the time but maybe don't think too much about, the trapezoid and the kite. Now they're both four-sided figures, but they play by a completely different set of rules. So, what's the secret sauce that makes a trapezoid and a kite a kite? Let's dig in.
So yeah, at a glance, they're both quadrilaterals. 4 sides, 4 corners. Simple enough, right? But what's that one single property that defines a trapezoid? And what makes a kite fly, geometrically speaking? Well, it all boils down to a few key characteristics, and that's exactly what we're going to break down today.
Here's our game plan. First, we'll get on the same page with some basic definitions. Then we'll decode everything about the trapezoid and even see how to spot one on a graph. After that, it's time to meet the kite. And to wrap it all up, we'll build a quick and easy field guide to tell them apart.
All right, let's kick things off with section 1. You know, in geometry, the definitions are everything. A shape is literally just a collection of its properties. And once you know those rules, you can unlock all of its secrets.
So, what's the common ground here? It's pretty simple. Both trapezoids and kites belong to the quadrilateral family. That's just a fancy name for any polygon with 4 sides and 4 angles. But honestly, that's where the big similarities end, and where the really interesting details start to pop up.
Okay, let's dive into our first shape. It's time to put the trapezoid under the microscope. We're going to break down its anatomy piece by piece so you know exactly what makes it tick.
I want you to focus on one word here, because it is absolutely crucial. Exactly. A trapezoid has exactly 1 pair of parallel sides. Not 2, because that would make it a parallelogram, and not 0. This one single rule is its entire identity. It's what makes a trapezoid a trapezoid.
And just like any shape, it's got its own anatomy. Those 2 sides that are parallel, we call those the bases. You can kind of think of them as the floor and the ceiling. And the other 2 sides, the ones that aren't parallel, those are its legs.
Now let's talk angles. Any 2 angles that touch the same base are called a pair of base angles. And what's cool is that this means every single trapezoid actually has 2 pairs of them. 1 pair along the top base and another pair along the bottom base. And this picture here really puts it all together beautifully. You can clearly see the parallel bases, those non-parallel legs on the sides, and of course the 2 pairs of base angles. This is your textbook A+ example of a trapezoid.
But wait, what if we throw in a little twist? What happens if those 2 legs are congruent, meaning they have the exact same length? Well then, you get a special, much more symmetrical version called an isosceles trapezoid. It's the same idea as an isosceles triangle, which, as you know, has 2 equal sides.
Okay, so we've got the theory down. That's great. But how can we actually prove a shape is a trapezoid using cold, hard numbers? Well, for that, we need to take it out into the wild of the coordinate plane and run a few tests.
So this is a classic challenge in geometry, right? If I just give you 4 random points plotted on a graph, how can you prove, mathematically, what kind of shape you're actually looking at? The answer is you have to use its fundamental definitions.
So here is our mission. We've got 4 points, O, R, S, and T, plotted right here. The goal is to first prove that this shape is a trapezoid, and then, for bonus points, figure out if it's a special isosceles trapezoid.
So here's our 2-step plan of attack. For step 1, we're going to calculate the slope of each side. Remember, if a pair of opposite sides has the same slope, that means they're parallel. Bam! For step 2, we'll find the length of the legs, the non-parallel sides, to see if they match. And the results are N. The slope of side RS is 1/2. And look at that, the slope of side OT is also 1/2. Since they have the same slope, they are parallel. The other 2 sides? Totally different slopes. And there you have it. With exactly 1 pair of parallel sides, we have officially proven this shape is a trapezoid.
But what about part 2? Is it isosceles? Well, we just need to measure the legs. The length of leg RO is exactly 3, but the length of leg ST is the square root of 8, which is about 2.82. Those are not equal. So our final verdict is ORST is definitely a trapezoid, but it is not an isosceles one. Case closed.
Awesome. So we've pretty much got the trapezoid figured out. Now let's totally shift gears and say hello to our second shape of the day, the kite. It's another 4-sided figure, but as you're about to see, its properties are in a completely different universe. Okay, the very first thing you need to know about a kite is that it has 0 pairs of parallel sides. None. Nada. Instead, a kite's definition is all about its adjacent sides. That is, sides that are right next to each other. See how there are two pairs of equal-length sides, and they're touching? That's the key.
Let's dive right into a little puzzle to see one of the kite's coolest properties in action. Imagine you've got a kite, and you know its four inside angles are 3x degrees, 75 degrees, 90 degrees, and 120 degrees. How on earth could we figure out the value of x?
Well, here is the secret you need to crack the code. In any kite, there is exactly one pair of opposite angles that are congruent, or equal. It's not about the angles next to each other like in a trapezoid, it's all about the angles directly across from each other. Okay, let's do the math. We know all four angles in any quadrilateral have to add up to 360 degrees. So we set up our equation, do a little algebra, and we find that x equals 25. And now, check this out. If x is 25, that mystery angle 3x is actually 75 degrees. So the angles are 75, 75, 90, and 120. We have exactly one pair of equal opposite angles. It fits the rule perfectly.
Phew, we have gone through a lot of rules and definitions. So let's bring this all home with a super simple, powerful tool I like to call the Quadrilateral Field Guide. It'll help you tell these shapes apart in a split second anytime you see them.
This chart right here is your ultimate cheat sheet. Just look at the core difference. Trapezoids are all about having one pair of parallel sides. Kites, on the other hand, are all about having two pairs of congruent adjacent sides. That one single distinction is what causes all the other differences in their properties, from their angles to their symmetry.
You know, this isn't just about lines on a piece of paper. These shapes are literally everywhere you look, in buildings, in art, even in nature. So now that you know the rules of the game, I have a challenge for you. The next time you see a four-sided object, ask yourself, is that a trapezoid or is it a kite? Happy hunting!